In the very first lecture of organic chemistry, we have already discussed about origin of organic chemistry. In this video, we will discuss about the concept of isomerism. If we look at the structural formula of methane and ethane, we will notice that each have only one kind of hydrogen, that is 4 hydrogen atom in methane, all are equivalent, and 6 hydrogen atom in ethane, all are equivalent. Removing any of the 4 hydrogen atom of methane and any 6 hydrogen atom of ethane, only one kind of methyl and ethyl group result. In homologous series, we notice that propane and butane each have 2 different kind of hydrogen atoms. In case of pentane and hexane, each have 3 different kind of hydrogen atom, A, B and C. These are different kind of hydrogen atom and so on. The simplest way to tell how many kind of hydrogen atom a compound contain is to replace each hydrogen one at a time by some other atom such as chlorine. If we replace one hydrogen atom of methane by chlorine, it will give only one compound, methyl chloride, and replacement of any one hydrogen atom in case of ethane, it will give only one compound called ethyl chloride or chloroethane. However, replacement of one hydrogen atom at a time in propane would give 2 different compound, propyl chloride and isopropyl chloride. Similar difference we see in butane and isobutane. Although butane and isobutane have same molecular formula C4H10, but they have 2 different structure. In case of N-butane, all carbon atom are in a single chain, but in case of isobutane, one carbon atom is present in a branch. So the compound that have same molecular formula but different structural formula are called isomer. Isomer is derived from a Greek word iso means same and mers means part. Isomer have the same kind and number of atom, but their atom are arranged differently. There are different kind of isomers or isomerism: structural isomers, functional group isomers, positional isomers or stereoisomers. Now we will discuss or explain one by one. Structural or constitutional isomer. The isomer have the same number and kind of atom, but their atom are connected in different order. For example, in case of butane, both have same molecular formula, but their atom are arranged in different order. There are number of possibility for branching in alkane. For example, in case of pentane, there are 3 isomer possible for pentane: N-pentane, isopentane and neopentane. In case of N-pentane, all carbon atom are in straight chain, while in case of isopentane, one carbon atom is present in branch, and neopentane, 2 carbon atom are present in a branch, and mean normal Iso mean branch 1 and new mean new. If we look at further in homologous series of alkane, in case of hexane, 9 isomer are possible. In case of heptane, 18 isomer. In case of octane, 35. In case of decane, C10H22, 75 possible isomer are present. In case of C11H22, undecane, 159 isomer are present, while dodecane C12H22, 355 isomer are possible. These structural or constitutional isomer have different physical property. They may differ, not always be large. But constitutional isomer will always be found have different melting point, boiling points, densities, or refractive index are different. Next one is functional group isomer. Functional group isomer are those compounds that have same formula but have different functional group. For example, in case of ethyl alcohol and dimethyl ether, both have the formula C2H6O, but one contain an alcohol group and the other contain an ether functional group. Ethyl alcohol and diethyl ether are different from each other. At room temperature, ethyl alcohol is a liquid and dimethyl ether is a gas. Ethyl alcohol reacts with sodium metal and diethyl ether does not. Similarly, melting and boiling point are different and their density and solubility are also different. In case of alcohol are soluble in water, but dimethyl ether slightly soluble. Next one is positional isomer. Positional isomer are the compound that have the same formula, same carbon skeleton and same functional group, but have the functional group located at different position. For example, along the carbon skeleton. For example, 1-propanol and 2-propanol. In case of 1-propanol, OH group is attached to carbon number 1. In case of 2-propanol, same OH group is attached to carbon number 2. Both these contain same functional group, but the functional group located at different position along the carbon skeleton. Next one is stereoisomer. Stereoisomer are those atoms connected in the same order but different three-dimensional arrangement. For example, in case of cis-2-butene, both methyl group are present at the same side, but in case of trans-2-butene, methyl group are present at opposite side. That's all about isomer and isomerism. If you like video, then subscribe my channel for more video. Thank you.